All right, determine the intervals of the domain over which the function is continuous. And here we are at number 44. And all it means for a function to be continuous, without getting too complicated, is this. Are you able to graph the function without having to lift up your pencil when graphing? All right, so here in number 44, we've been given the graph of some line and told that at the point P, which they're identifying as -1, -2, we have an open circle, meaning the graph does not exist here at this point. So what it means to be continuous is that we're able to start graphing this function. So we start down here. Remember, we go from left to right. And as we're graphing our function, we're graphing. And as we come to the point -1, -2, we have to physically lift up our pencil from the paper and set it back down again, and then continue graphing. All right? And because we had to physically lift our pencil off the paper at the point -1, -2, this function is not continuous. In order to be continuous, we need to be able to graph the function without lifting our pencil off the paper. All right? And because we had to here at this point, this function is not continuous. So now they want us to determine the intervals of the domain for which the function is continuous, meaning what part of the domain for this function can you graph continuously without having to lift up your pencil? Well, we know that this is a line, right? And it goes on in both directions forever. So this graph coming from this direction, right, as this line continues down to the left side of the screen, the x value is getting smaller and smaller out towards -infinity. So for our domain here, we'll go from -infinity, and we're graphing. It's getting bigger, the x value, getting bigger, until we hit this point P, and the x value from this point P is -1. And because it's an open circle, we're saying do not include that value, that x value of -1, as being part of the domain, so we have to use a set of parentheses to close this particular interval. All right, and then we're going to use the union symbol because we pick back up again at -1. And as we graph, the x value gets bigger and bigger, and it will continue to do so continuously out towards positive infinity. All right, so our domain for this particular function is from -infinity up to -1, but not including -1 because it's an open circle. And then it picks back up again at -1, but not including -1, which is why we use parentheses, and then continues to get larger from there out towards positive infinity. Excuse me. So again, continuous means, can you graph your function without lifting up your pen or pencil from the paper? If you can graph the whole function, then it is continuous. If you have to lift up your pen or pencil, it is not continuous. And hopefully you'll continue with your math series, and you'll get into the calculus series, and you'll study continuous functions in greater detail. But for right now, number 44, here is the domain over which the function is continuous.